So what I want to do in this note, I want to go over the questions that you guys that we did in the class, and I want to actually do it using formulas. Okay, so the first question is that you assume. So the questions are from the announcements. The first question is, assume you have a mortgage for 15-year paid bi-monthly, right? So a 15-year mortgage every 2 months. Okay, and the current yield is 4%. What will be the mortgage bi-monthly payment if it's 15 years? Okay, so first of all, notice the strange features they put here, right? I said that the mortgage is going to be paid every 2 months. So I just want to emphasize that the formulas are not valid for the only case where you are thinking about, okay, which is usually monthly mortgage, right? But as I said in class, it can be also bi-monthly, quarterly, 4 months, you name it, okay? So where we want to calculate in this question, we want to calculate the payment. So it's actually pretty easy to do if you remember the magic formula that if you have X payment, which is a mortgage payment, every fixed amount of years, okay, the present value of these payments is going to be X divided by Y, adjusted, and adjusted means that I will take the 4% and I will adjust it to the yield in 10 months. 1 minus 1 plus Y adjusted to the power of n, and n is the number of payments. So this must equal to the present value of the mortgage, which equals in this case 100,000. So then you can find X to be P times Y divided by 1 minus 1 plus Y to the power of n. You just solve it, right? It is high school algebra, hopefully you know it. Okay, so now you need to actually substitute the numbers. So this is not hard. So what you want to do, you want to find the Y adjusted here. And to find the Y adjusted, you just need to take your 0.04 and you divide by 6. Why? Because you have 6 periods, 6 payments per annum. And now you just need to substitute. So you have 100,000. So your Y adjusted in this case is going to be, I think, 66.7, something like this. Right? You multiply by 0.0667, whatever, and you divide by 1 minus 1 divided by 1 plus 0.0066 to the power of 30, now to the power of 90. Why do we have 90 here? Well, we have 15 years and we have 6 payments per annum, right? So overall we have 15 times 6, which is going to be 90, okay? So when you calculate this, and hopefully you can calculate it either in Excel spreadsheet on your calculators, right? You're getting 1481 17 or something like that, okay? So that's going to be your bi-monthly payment. It's going to be 481.17, okay? Now, what I want to do, I want to answer some of the questions. I will not answer all the questions. I want to answer some of the questions, okay, using the formulas. So the question is, let's say, what is the amount outstanding after 5 years? What is the interest paid total in first year, etc., etc., etc. So I gave the formulas in class. So the basic principle behind it, that the first step is to find the present value of the principal paid. Okay, so let's assume that you want to find your amount outstanding after 5 years. How do you do this? First of all, you find the present value of the principal paid. Okay, it will be equal to all payments, So principal paid at each payment. Okay. Then you find the principal paid. Okay. At each payment. Then you find the interest. And once you have the interest, you find the amount outstanding. So if you want to find, right, so this you're doing without the spreadsheet, you just do it directly, okay? So it's important to emphasize there are two ways to do it. The first way is just to create a spreadsheet like I created in class. Here, I'm giving you the algorithm, right? I'm giving you the method, or basically I'm giving you the formulas to do it. So first of all, how you find the present, so let's assume that the problem is find the amount outstanding after 5 years. Okay. So the first thing to do, you want to find the principal paid. And the principal paid is a beauty that you can find from the first payment. That's the formula that I gave you in class, that it's x minus p times y divided by 1 plus y. Okay? So in this case, the present value of the principal paid is going to be 1481 It's 1481.17. That's going to be your B monthly payment. Then you subtract the principal value paid, the 100,000 times the 0.066 whatever, and you divide by 1 plus 0.006 whatever, right? That's your adjusted yield. And here you're going to get your coveted present value principal paid, which is going to be 809, 1009, or 1009 or 809.11. Okay? Like this. Great. So we found now this is going to be constant across all payments. So you can actually use that in order to find now the principal paid at each payment. So, for example, let's say k equals 30, right? So you will get here 809.109. So this is going to be your present value of the principal paid at payment 30. Why payment 30? Payment 30 because you have 5 years times 6 payments, each year 30 payments. Okay? So you know this, now you want to actually take it forward. So watch how the concept evolves. So you have that the present value of the principal paid, right, is 809,109. So the principal paid is going to be 809,109 times 1 plus 0.066 to the power of 30. Or it equals to 481 minus 17 minus 10 times 0.0066 right? Times, and now you take 1 plus 0.0066 to the power of 29. Why 29? Because look here. Okay? Look at this guy. This is coming from here. Okay? So both are equal, and the principal pay that you guys are going to get after 30 years, right? It is going to be 987,052. So when you do this calculation, you get 987,052. Okay? Just like we had, or 987,59, sorry. Sorry about that. 5.9. Okay. So that's how you find. So first, the first thing is to find the present value of the principal paid. The second, what we did here, right? Find the actual principal paid. And how I did it, right? I took my present value times 1 plus y to the power of n, which equals x to the p times y times 1 plus y to the power of n minus 1, k minus 1 here, where k is my payment. Okay? The concept is very simple. You have the present value, and then you push it forward to the searches payment, and you find how much principal is paid. Once you have the principal paid, okay, you get the interest paid. What is the interest paid? It's very easy, right? If you have your payment minus your principal paid, it's going to be your interest paid. In our case, right, it's going to be 487 point whatever we had there, 1481.17 minus, and the principal paid we had 987.59. So overall we're going to get now here 493.577, okay? And if you use the formulas, okay, so you can actually say that this is going to be x minus p times y divided by times 1 plus y to the power of k minus 1, right? And so this is going to be interest paid. And now, once you have the interest paid, you can find the amount outstanding by just taking interest paid divided by y, which is the amount outstanding. Why? Why is it true? Because amount outstanding times y equals to interest paid, right? So I just take the IP divided by y and I get my amount outstanding. So in this case, okay, it is going to be 493 divided by 100 whatever, right? And this is going to be 036 and 59, right? So this is, okay? So that's it. Now, so this is actually the direct way to find the certain pieces of the mortgage payment, of the mortgage, of the mortgage balance sheet without going through the motions of the spreadsheet. Because if I'm going to give you, let's say, a 30-year, right, mortgages, it is much more convenient to use this kind of argument than, to actually recreate the spreadsheet for 30 years. Okay, so hopefully it's actually, makes sense now much more, and so the only thing is, right, that some of these problems need common sense. Let's say the second problem is a break-even problem. Okay, so the break-even is, okay, so you have a mortgage payment, and you have real estate tax. So how much rent you need to buy, to charge in order to actually make ends meet on a monthly basis, you need to charge the sum of them. So in our case, in the question 2, when I was talking about the break-even, the mortgage payment stays the same because you take the mortgage of 1481, 17. Now you need to add to it the tax. Now what is the tax? You have $100,000 and you multiply by $150,000. You multiply by 2%, which is your real estate tax, and the real estate tax is coming from the house price, not from the mortgage, right? You have 3,000, but you need to take this 3,000, you need to divide by 6, which is 500, right? So you need to take this 1481 and add 500 to it in order to meet your ends pay, your payments, right? So it's kind of straightforward, but you know, I actually, this is kind of finance, right? Finance is not rocket science. It's basically these kind of calculations. And I think it's important for you guys to understand where those calculations are coming from, okay? Now, the other questions were here, right, in this email, were about coupon paying bonds. And as I told you, right, once again, you have the magic formula, x divided by y times 1 minus 1 plus y to the power of n, plus the principal divided by 1 plus y to the power of n. This is if you know the payment, and if you know the coupon is c divided by 1 minus 1 plus y to the power of n, plus 1 divided by 1 plus y to the power of n, and you multiply by p. Okay? So, once again, right, this y is y adjusted. And here is also y adjusted, and c adjusted, of course. Okay? So, if you have something like that, right, how do you, so a problem was that you have a coupon paying bond of 5%, which is paid quarterly, maturing in 3.5 years. What is going to be the price of this bond is the principal is $100, and the current discount yield is 4%. So, in this case, right, you have it quarterly. So it's 4% annum, and per quarter is going to be 1% adjusted. You just take the 4% divided by 4 because you have 4 quarters. And the coupon is 5%, you divide by 4, right? You get 125%. Now, what is your payment? Your payment in this case, okay, is going to be 125 because the principal is 100. So it's 100 times 125% is $125. Okay? Pretty simple. So now how do we approach this problem? So let's see how you approach this problem. So basically, you have x. You have x here. So I'm going to use this formula here. Okay, so you have x, which is 125. Okay, which is you divide by basically 0.01. Multiplied by 1 minus 1 plus 0.01. And now how many payments you have? Well, you have 3.5 years, right? And you have 4 payments every year, so you have 14 payments. And then you add to it 100 divided by 1 plus 0.01 to the power of 14. Okay? And you get whatever result you get. You know, you get the result. And that's how you actually going to get. So the result, I think it's 103.25. Now, in this formula, you have two portions. This is a portion of the principal, of the interest, if you want, or the payments. And this is a portion of the principal, what you pay at the end. Okay, so the timeline looks like this. So if this is going to be your timeline, this is 0, let's say until 14. And so every 2 months, you're making a payment of 125. And at the end, right, you're making a payment of 125, but then you make also a payment of 100. So at the end, you are going to make a payment of 101.25. And what you do, right, you find the present value of each of these payments. So it's going to be the first payment is going to be 125 plus 1 over 0.01. The second payment is 125 divided by 1 plus 0.01 square, etc., etc., etc. Now this right, is actually summed by this formula. Now, at the end, right, you have your principal part, which is coming from here. Okay? So the answer here is 103.25, and hopefully, you understand now better how it works, and that's it. Okay? The last question is basically for zero coupon bonds. And the first is actually to take it with a continuous compounding. And the second one is to take it with discrete compounding, right? So the discrete compounding is going to be quarterly, right? So and y in this case is going to be 3%. So when you divide by 4, you're getting 75 basis points, I think. So it's 1 divided by 1 plus 0.075, and then to the power of 14. But here, it is much easier. It's exponential, minus 0.03 times 3.5, and you're done. So that's why I prefer this continuous compounding versus this, because here, right, it's more cumbersome. You have more steps to do. You need to take your y, you need to adjust it, etc., etc., etc. Okay? So hopefully it helps you to understand the concept a little bit better and prepare for the test. And I'll see you tomorrow on Wednesday. Thanks and have a great day.